Okay, so let's talk about the myopia and your hyperopia. So what is myopia? Myopia is also known as your nearsightedness or short-sightedness lah. So where the image form is in front of the retina. So for people with your short-sightedness like us, right? So like us, we wear spectacles. So this is known as your myopia. So what do I mean by myopia? Myopia means you can actually see close object. But far object, they will appear very blurry because the light doesn't converge exactly at the retina here. So that's why when you can see that the three light rays are parallel. Parallel light ray means that the light actually is coming from a very far object. So for far object wise, we cannot see. So how do I correct this type of eye problem? So you can just place a diverging lens, because I can place a diverging lens and cause the light ray to actually converge exactly at the retina. Alright, so that is the meaning of myopia. Okay, so for hyperopia means long-sightedness, which occurs when the image is formed behind the retina. So this is also known as the 老花. So far object can be focused, but close will appear blurry. So this can be corrected by placing a converging lens in front of the eye. Because if you place a converging lens in front of the eye, right here, this can actually converge the light ray, right, to exactly the retina, so that you can see the image clearly. Alright, okay, so let's look at checkpoint 11. So you can try the checkpoints first before you look at this video. So for checkpoint 11, a lens form a blurred image of an object on the screen. So how can an image be focused on the screen? So you can see that the screen is right here, and the so-called the two light rays are intersecting at this particular location. So this means that the image form is exactly here. So how do I make sure that the image form is focused on the screen? Is either I can move the screen to here. So I can move the screen to this point. But apparently there's no such answer, right? Okay, so let's take a look at all the options that is given to us. So A, move the object away from the lens and the screen. So you want to move the object to maybe this point. This is not correct, because if you move the object to this particular location right here, the image former will be right here. So it's even further away from the screen, right? So this is wrong. Okay, what about B? Move the screen away from the lens and the object. This is even worse. Alright, so C, use a brighter object at the same location. Okay, so this will not cause anything. The image will still be blurry. So last but not least, use a lens of longer focal length at the same position. So this is the correct answer, because if you use a lens of longer focal length, right, so this can actually cause the light ray, right, to intersect at exactly at the screen. So for example, if I go back to the simulation, okay, so let me just go here. Okay, so imagine that we have an image at this particular location. So I have a screen exactly at the 2F, the second focal point on the right hand side of the lens, right? So how do I make sure that the image form is exactly at 2F? I can simply increase the focal length. So when I increase the focal length, right, I will cause the image to be formed exactly on the screen. Okay, so that is the idea. Alright. Okay, so of course I go to checkpoint 12. Okay, checkpoint 12, same thing, is the diagram shows a lens forming a blurred image of an object on the screen. So how can a sharp image be obtained on the screen? So first thing first, you can see that the two light rays are intersecting exactly at maybe this point. So the only way I can do is maybe I can move the screen to this particular location right here. Okay, so let's take a look at what are the options given to us. So number one is by using a lens of longer focal length. So if I use a lens of longer focal length, right, so the two light ray will intersect even further right here. Okay, so it will intersect exactly maybe right here. So it's not going to form a very focused image. Okay, number two, by moving the object towards the lens and the screen. This is also wrong, because if you move to here, the image will also move away from the lens. So number three, by moving the screen towards the lens and the object. So if I move the screen here, this is wrong, because it's away from the image. Okay, number four, by using a lens of shorter focal length. So this is the correct one, because if you use a lens of shorter focal length, this will cause the image, the two light ray, to intersect exactly at the screen right here. Okay, so this is number four. Okay, so let's go to checkpoint 13. So checkpoint 13, with this object, shows a thin converging lens forming a real image of an illuminated object. So what happens as the object is moved towards the focal point F? So I move the object towards here. So of course, let's take a look at the option. The image A, the image move further away from the lens and decreases in size. Okay, the first statement is correct. The image will move further away. So just think of it as, okay, keeping a social distance, right? So for example, let's just say me and you, we are keeping a distance of 1 meter. So when you move forward, when you move towards me, I must move away from you to keep the same 1 meter distance, right? So the first statement is correct, but the second statement is wrong. Decreases in size, but it should increase in size. So let's take a look at B. The image move further away, said correct, and increases in size. This is the correct one, right? So the answer should be B. Okay, let's go on to checkpoint 14, where we have this magnifying glass. So which point is the principal focus of the lens? So the principal focus of the lens, you just have to look at this particular line. So this particular line, right, will form a straight line with the so-called solid light ray. So this point D will be known as your first focal point. Okay, then the option C is actually your optical center. So this is for checkpoint 14. So the answer for this is Denmark. Okay, now we go to checkpoint 15, where we have this object of height 5 cm is placed 2 cm from a converging lens, which is being used as a magnifying glass. The image produced is 6 cm and has a height of 15 cm. What is the focal length of the lens? So same thing, is very similar to your checkpoint 14. You just have to draw a dotted line. Then after that, you draw a solid line. So this solid line is going to pass through your 3 cm, and 3 cm will be known as your focal length, because focal length itself is known as the distance between the optical center to first focal point, right? So the answer will be B. So now I move on to checkpoint 16. Okay, checkpoint 16 is a rather challenging question from 2010. So it's about 12 years ago. Okay, so the diagram shows the path of two light rays from an object, and the object is 10 centimeter in front of a lens in the position shown. What type of lens is this, and what is the focal length? Okay, so by one look, you might be mistaken that this one is actually a diverging lens, because you can see that my light ray is diverging, right, from one another. So that's why it's a diverging lens. But actually it's not a diverging lens, it's actually a converging lens. How do I know? Okay, let me erase this. So if you look at the first light ray and the second light ray, the second light ray is not going to help in anything, because it's just passing through the optical center. So the only thing that will help us is actually the first light ray. So first light ray, you notice one thing, right, is that, okay, first I draw a light in this particular direction. Okay, then after that, right, the light, you notice is that it will bend a bit. Okay, imagine that there's no lens in this question. If there's no lens in this question, the light ray will just go straight like this, right? But now I put a lens in this position, you'll see that the light will bend like, towards here, will like converge lah. So this is actually a converging lens. So answer is either A or B. Then after that, okay, then the next thing is what about the focal length? Okay, focal length is either greater than 10 centimeter or less than 10 centimeter. So if you look at the right hand side of the lens, so let me just erase this. Okay, if you look at the right hand side of the lens, you will see that the light is not going to converge. It's like going away from one another, right? So it's not going to converge, and means that the image is not going to be formed on the right hand side of the lens. So the image, it was going to be formed on the left hand side of the lens. So left hand side of the lens means that it's actually a magnifying glass. So this question is actually testing us on whether we know that, this is a magnifying glass. So of course, where is the location of the image, right? You can simply extrapolate like this. Okay, let me just answer this first. Okay, you can actually extrapolate like this. After that, extrapolate here. So you can see that my two dotted line is gonna be intersecting at this particular location. So this will be your image. So this is actually a magnifying glass, and we know that magnifying glass, right, the object must be placed in front of the first focal point. So the first focal point must be more than 10 centimeter, or what we call the focal length. Focal length must be more than 10 centimeter. So the answer for checkpoint 16 is actually A. Alright. So for checkpoint 16, many students will choose either C or D lah. Also just take note of this. Right? Okay. Another way to see whether is it a converging lens or diverging lens, you can actually maybe draw something like normal right here. So you can draw a normal. Then you see that my light ray actually converge towards the normal. So this is another way of saying that is a converging lens. Okay, so now I move on to checkpoint 17. So checkpoint 17, which diagram shows a ray of light passing through a converging lens? Okay, so you look at A. A, you will see that it's actually a diverging lens, because you can see that my light ray is diverging right from one another. Okay, so I think let's use another way to describe. Okay, for option A, if I don't put the lens, the light is just going to go in this particular direction, right? So I put the lens now, so the light is diverging. So option B, so let's say I don't put the lens, the light is going to just go in this direction. So I put back the lens, you are going to converge. So of course you can see that the answer is B already lah. Of course, let's move on to option C and D first. Okay, option C, I don't put the lens, the light is going to travel in this direction. I put the lens, you can see that it's diverging. Okay, last but not least, D, I don't put the lens, the light is going to travel in this direction. I put back the lens, is diverging. So the answer for this is actually B for Brazil. Okay, for checkpoint 18, so same thing. We have these 4 rays from point O entering a diverging lens. So the phase PQ of a diverging lens is part of the circle, which O is the center of the circle. So which ray will follow the correct path? Okay, so for diverging lens wise, you will need to first eliminate 2 options. For option A and B, A and B is actually more of a converging lens. So we must eliminate this and this. Okay, now we go to your C and D. Okay, let's take a look at C first. Okay, C, you can see that the light ray, okay, this is the light ray here. So light ray will enter. So one thing to take note is that, okay, this is emitted from the center of the circle. So there shouldn't be any bending. Because why is there no bending? Because this is perpendicular. Remember the geometry that I teach you all. As long as the light cuts through the center, this will be perpendicular right here. Then after that, if it's perpendicular, right, the light will just go straight through. Then after that, when you exit the lens, it's going to bend away. So if I draw a normal, it's going to bend away. Okay, for option D right here, you can see that there's a bit of bending right here. So it's not going to be the correct answer. Because it's perpendicular. If it's perpendicular to the surface, it's not going to refract at all. So the option D actually gave itself away already. So the answer for this is C. Okay, so these are all the lens question. Yeah, I think that's about it for the lens. All right.